Okay, we're going to do grab your chapter 7 note packet, the one that has 7.6 and 7.7 in it. We're going to do some problems from, we're going to do the notes for 7.6 and 7.7. I think you'll find it to your liking. I enjoy it very much. Start with this warm-up question, which comes to us from 7.5. Just a little reminder about some of the important things you need to pay close attention to. This has 2 logs and then no log over here. So this one, remember, if there's logs everywhere, you're getting 1 log equal to 1 log. And then you can drop the logs and solve. This is one where you need to write it in exponential form. I would start by applying the product rule, which would tell me the log base 6 of x times x minus 9 equals 2. And now I would rewrite it in exponential form, which means base raised to the exponent. So I would actually leave this one here, and I would multiply this all at the same time. X squared minus 9x equals 6 to the second, which gives me x squared minus 9x equals 36, which means I have a quadratic equation. X squared minus 9x minus 36 equals 0. Which means I'm going to need to factor. And what do we multiply together to get negative 36 and add together to get negative 9? I believe, if my math is correct, it has something to do with 12 and 3. So I need a negative 12 and a positive 3. Check your work by foiling it back together. X squared plus 3x minus 12x. There's my middle term. That's the key. And then I have a minus 36. X is 12, or x is negative 3. Make sure you go back to the original problem. I can be 12 here. I can be 12 here. That's 12 minus 3. Can I be negative 3 there? I cannot. That's an extraneous solution. My answer is x equals 12. You must check your answers. You can't take the log of a negative. Little reminder from chapter 7.5. Today we're going to do common logs. Common logs are base 10. The base will always be 10. This is the one that is on your calculator. You can see it on the calculator. If I call up the calculator, the log that is right here is on the, that's going to be the log base 10, the one on the front of the calculator. So we'll learn some stuff to do with that here today. Show you a couple of things here. We do not write the 10, much like when we don't write the 1, we don't write the 10. It's there. We don't, like the square root of x is x to the 1/2. We don't write the 2. The cube root of x is x to the 1/3. 17 to the first power is 17, but we don't put a 1 on it. If you have a log and there's no base given, you assume that it is base 10. It's the most common log that is ever used. If you take a look at the log 7, what does this mean? This is going to be, if I wrote this as, first of all, type it into your calculator and let's calculate it up. Let's see what we get. So I do log 7. I'm going to have to close the parentheses. I got 0.845. So if you go back here, approximately 0.845. Remember, squiggly equal signs means approximately. It means I'm rounding. What does this mean exponentially? It means 10 to the 0.845 is equal to 7. Remember, exponential form, 10 raised to the power. That's what this means. You can check your answer. 10 raised to the 0.845. And I get something pretty darn close to 7 because I rounded. So for the common logs, when we do these guys, we're going to have the log of 0.5. So what we're looking for here is 10 raised to what power? 10 raised to what power equals 0.5. Calculator will do it for us. Log 0.5 negative 0.301. And if you think about that, negative 0.301. How do I get 10 to be a number that is a fraction? How do I get the number 10 to be a fraction? I'm going to need to put, I'm going to need to get it in a fraction form, which is why we have a negative value there. So 10 raised to the negative 0.301 is 0.5. That's what this would say right here, negative 0.10. There's a 10 there, even though it's not written. So none of this is really all that new. And now we get to solve things on our calculator. Richter scale. Whenever they give you a measurement on a Richter scale, they are talking about the exponent that is on the 10. So logarithmic scale used by the Richter scale is based on the powers of 10. Magnitude of 6.4 means it's 10 to the 6.4. So it's logarithmic form. There's a couple word problems that will come up with that. This is where common log is going to be the most useful. Just like you're allowed to multiply both sides by a power of 10, you are allowed to, or multiply both sides by anything of an equation. This is where we start solving for variable exponents. What we're allowed to do here is we're allowed to take the log of both sides. So I'm going to do log of 5x and log of 62. Now, based on what we learned in 7.5, this is the beauty of the power rule. The power rule tells me that if I have a log on both sides, or a log right here, I'm allowed to swing that log out front. X log 5 equals log 62. Now, log 5 is just a number. We just did it back here. Log 5 is the number negative 0.301 that we can get on our calculator. Our calculator does it for us. So if I'm solving x times a number, I can divide both sides by the log of 5. I can divide both sides by the log of 5. So you grab your calculator and you type in log 62 divided by log 5. Simple as that. So this is how we're going to solve for variable exponents now. So I type log 62. Got to close that parenthesis, divided by log 5. So what we're looking for here is really the exponent that you raise the 10 to get 62, and then the exponent that you raise a 10 to get 5. That's what we're answering. And my answer is 2.564. So x equals 2.564. How do I check my answer? Grab your calculator. Take the number 5, raise it to that 2.564. What should I get? A number pretty darn close to 62 because I rounded again. What did I get? A number pretty darn close to 62. Whoomp, there it is. Next one, take the log of both sides. I can do log 3 to the x equals log 17. Swing the x out front. Log 3 is just a number. It's a number that our calculator finds. It's the number that we raise the number 10 to. Divide by log 3. Divide by log 3. X equals whatever log 17 divided by log 3 is. I get 2.579, approximately 2.579. 3 squared is 9. 3 cubed is 27. It should make sense that 2.579 is going to be 17. This will be probably the biggest problem. These are the biggest types of problems that you have to solve. So if you're going to pay attention today, you already should have been paying attention, and you should pay attention right now. Because when we are going to solve something like this, I've got variables on both sides now. 9 to the b minus 1 equals 7 to the b. I'm going to take the log of both sides. So I have log of 9b minus 1 equals log 7b. I think that's probably hard to see, so I'm going to actually thicken this up. Okay, power rule says swing this out front, swing this out front. I get b minus 1 times log of 9 equals log of 7. That's too thick. Now, this is just a number, and I've lost my b here. B times the log of 7. And this is just a number. So what I need to do is I need to get the b's together on the same side so that I can factor them out. I currently have 2 of them. I'm going to distribute the log 9. I have b times the log of 9 minus the log of 9, that's the distributive property, equals b log 7. So I'm going to move the log 9 over here, and I'm going to move this term with a b over here. I get b log 9 minus b log 7 equals log 9. Why did I get them together? I got them together so that I can take the b out. Log 9 minus log 7 equals log 9. Now, I could go right here and I can divide both sides by log 9 minus log 7, or I could recognize from what we did in 7.5 that this could be rewritten as b times log 9/7 equals log 9. Remember, subtraction of logs with the same base, you can turn it into a multiplication problem. And now I can divide both sides by log of 9/7, log of 9/7. And that's what will go into my calculator. Grab your calculator, log 9 divided by log 9/7, and it'll be wonderful. It's the hardest problem you got to do. Log 9 divided by log 9/7. My answer is 8.74. My answer is 8.74. Now think about what that means. Back to the original problem. 9 raised to the 8.74 minus 1. That would be 7.74. Is that equal to 7 to the 8.74? Well, could we check that on our calculator if we really wanted to? You're darn right we could. Let me see if I can see that answer there. Is 9 to the 7.74 the same as 7 to the 8.74? 7 to the 8.74. If I've done this correctly, then these should be darn near the same number. That's a 24,312,000, 24,330,000. Why the discrepancy? Because I rounded. There was more behind the when you're raising an exponent to something that's rounded, your error will kick in that much more. I would call those pretty darn close. We are good. So take the log of both sides. Get the variables together. So if you're looking for steps when you have the multiple variables, 1, take log of both sides. 2, if you need to distribute, distribute. And then you want to get the variables together on one side. Get everything else on the other side. 3, factor the variable out because you have them grouped right here. I have them grouped together. And now you want to, 4, you're going to simplify to make your life easier. That's where I turned it into 9/7. Simplify and solve. And of course, always check your work. So those are the hardest problems that you got to do for today. Change base formula is a lovely little thing. Tells us that if we have log base a of n equals, we can put the n, which is what we're taking the log of, can be any base. You can change it to any base. Why would we want to change something to any base? Because our calculator has the common log on the main page, and the a goes on the bottom. So we have log base 3 of 11. 11 goes up, 3 goes down, and now we can type into our calculator log 11 over log 3, and it solves it very quickly. Some of you had already done on math. If you go to math and you go to number, and if you scroll up, I thought it was on here. Maybe it's just under the math key. Let's go back to the math key. Scroll up. There it is. If you hit math, and then it's under A, or just hit the up arrow or the down arrow until you get to log base. Most of your calculators will do this. So that example that we just did, log base 3 of 11, you can type this in there. But if they ask you to use the change of base formula, you're going to change it into the log base 10 of 11 divided by the log of 3, which is actually quicker because you have it on your main screen, and you get the same answer. So here's a great example of the fact that log base 3, that goes to the bottom, becomes the log base 10 of 3. The 11 goes on top. The base goes to the bottom, pretty easy to remember. A couple of quick examples. So they're going to ask you to express in terms of the common logs. That's where you're going to use the log 140 over log 5. Plug log 140 over log 5 in your calculator. Boom, you're done. Down here, base goes to the bottom. 16 comes up. Log 16 over log 5. Boom, you're done. Type it into your calculator, and you're good. That's the change of base formula. Pretty slick. And that's the end of 7.6. So 7.6 is everything to do with common logs, log base 10. Now, if you look on your calculator for base E, the first thing you got to do on your calculator is identify the natural log. So the ln is it's called the natural log, and they use it as ln, and it has a base of e. E is just a number. Where is the e? If you go second and the division sign, you will find the number e. E is just a number. It is 2.718281828, etc. So what you got to remember is e is a lot like pi. It is not a variable. It is a number. So when we take a look at a couple things here, it says the value of e. So all of the rules for these things will apply. So how do we rewrite this in log form? It has a base of e, so automatically it's ln. A log is equal to an exponent, so this would be ln 23 equals x. There's an e there, we don't write it. It's e to the x equals 23. Over here, if you wanted to write this in log form, ln, again, it has a base of e. Don't be afraid of this. Of x equals 4. This can be typed right into your calculator, ln of 23, it'll be solved. This one, I don't know why you would want to write it in log form. They asked us to. E to the 4th, you can type that into your calculator. That's 2.718 whatever to the 4th power. Pretty easy to solve. Try a couple of more. It wants it in log form. Again, we use ln. There's a base of e. It's right here. We wouldn't write it. It's not written. Just like the 10 is not written on the common log. Of 15 equals x. E to the x equals 15. And down here, that's the same problem as the other one, isn't it? ln of x equals 4. E to the 4th equals x. So all the same rules as what we had earlier. Write in exponential form, what is e to the 1.2528 equals x. Now I would type that into my calculator and I would solve for x. There's an e there, even though it's not written. There's an e here. E to the x equals 25. If I wanted to solve this one for x, I would just type the ln 25 into my calculator. All of the same rules for what we've been doing will apply to natural logs. I would apply the power rule, and I'd put that up there. And then I would have ln of 3 squared, which is 9, plus ln 4, plus ln y. If I wanted it as a single, this would mean multiplication. 9 times 4 times y, 36y. And you're done. Down here, put the 4 up top. Write this as a single logarithm. ln of 3 to the 4th is 81 plus ln 6. That's multiplication. 81 times 6. 81 times 6 must be 320. What is it? 332, 400, 486. 486. There you go. Solve. Now instead of solving using log, common log, we will solve using ln's. So I do 3, and I do 3, and I do e to the negative 2x is 2. Now we're going to take the natural log of both sides, or we could be rewriting it in ln form. It's a good way to do it. A log is equal to an exponent, so I will have ln base e of 2 equals negative 2x. That's one way to do this guy. ln of 2 is something your calculator will do for you. Take and plug a negative 2 in. X is equal to whatever ln 2 divided by negative 2 is. I got ln 2 divided by negative 2. I got negative 0.3466. 4 places is fine. Negative 0.3466. Same thing up here. Minus 5, minus 5. 2 e to the negative 2x equals 10 divided by 2. So we're isolating the e value. And now another thing you can do is take the ln of both sides. And I would swing this out front. Negative 2x ln e equals ln 5. Hey, what's the ln of e? Let's think about that for a moment. E to the what is e? E to the what is e? Ln of e is equal to 1. So if that's 1, I get negative 2x equals ln 5. Divide by negative 2, divide by negative 2. Type ln 5 divided by negative 2 in your calculator. ln 5 divided by negative 2. ln of 5, natural log of 5 divided by negative 2. And my answer is negative 0.8047. Negative 0.8047. Going the other way here, you can divide by 2, divide by 2. ln of 5x equals 3. Now I want to rewrite this one exponentially. What's the base of a natural log? E to the third equals 5x. Divide by 5, divide by 5. Can I type e to the third divided by 5 in my calculator? You're darn right I can. Remember where the e is. Second and the division sign. E raised to the third divided by, what was it divided by? I forget. Divided by 5. Calculator does it for you. 4.017. 4.017. How nice is that? Compound interest formula called the PERT formula. Always remember it by the shampoo model. PERT, P times e to the RT. P is the principal. That's the initial investment. This is very similar to y equals a times b to the x. E is just a number. R is the interest rate. T is the number of years. So this is for continuous interest. If you can get, remember if it was compounded quarterly, the n was 4. When with that other equation, we had amount at time t equals the principal times 1 plus r over n to the n times t. That was our formula for compounded, and then n was monthly, it was 12, and so on and so forth. Now this is when we get interest compounded continuously. Amount after 8 years will be equal to the initial investment, $700, times E raised to the rate. We have to change it to a 0.03 times T was 8. So 700 times E to the 0.03 times 8. That will go into your calculator. 700 times E, second E, raised to the 0.03 times 8. Watch your parentheses depending on what type of calculator you have. We will have $889.87. $889.87. PERT equation. Principal times E. E is just a number raised to the R times T. This one, suppose you deposit $700 into a savings account paying 3%, very similar. How much would you have to be, well, how much would have to be deposited in order to reach a balance of $1,500 after 12 years? I think we're actually, this one's not worded right. To reach $1,500, A equals P-E-R-T. So we want to know $1,500 equals, we're looking for the principal, we don't know, times E to the rate is 0.03 times 12 years. So we can do 12 times 0.03, which is 0.36. So I can do divide by this e to the 0.36, divide by e to the 0.36. My calculator will do 1,500 divided by e to the 0.36. So we're looking for P dollars here. That was worded wrong. So I can grab my calculator and do 1,500 divided by e to the 0.36. $1,046.51 is what I should have started with. There you go. Remember, E is just a number. It's 2.718 and your calculator does it for you. So you got log base 10 is equal to just plain old log. And you got ln means base E, but we don't really write it. There you go. You're in good shape.